The following question compares the distance and direction between cities on a flat surface to the distance and direction between cities on a sphere. Consider a model where the cities of Bogota, Moscow, and Nairobi lie on a flat surface. In this model, Nairobi is 6,000 kilometers due south of Moscow, and Bogota is 12,500 kilometers due west of Nairobi, shown in the following diagram. Question AI. Find the distance from Bogota to Moscow. Since it's a right-angled triangle, the Pythagoras theorem can be applied, a hypotenuse is required, and it can be found as the square root of 12,500 squared plus 6,000 squared, and it is equal to 13,900 to three significant figures, kilometers. The next, find the bearing of Moscow from Bogota, give your answer in degrees. So we need M from B, so this direction BM is required, and by definition, the bearing angle is from north in clockwise direction, so this angle is required. And it can be found as 90 degrees, this angle, minus this. And for this, tangent can be found as this divided by this, and hence the angle is arctangent or tan. And -1, it means the inverse tangent of 6 over 12.5, and it is equal to 64.4 to three significant figures degrees. So the required bearing angle is 0.64 degrees, or more accurate 0.64.4 degrees, and as usual to three significant figures just 64.4 is also acceptable, but for bearing angles it is suggested the answer to be such that there are three digits for the whole part of a number, like this. The next. In reality, these three cities lie on the curved surface of the Earth, which will change the distances and directions found in part A. Now consider a curved model using a coordinate system XYZ with its origin O at the center of the Earth. The units of this system are thousands of kilometers, and the Earth is modeled as a sphere with radius 6,000 kilometers. The North Pole P lies on the z-axis, and Nairobi N is modeled as being on the equator and lying on the y-axis. P has position vector OP with component 0,06, and N has position vector ON with components 0,60. Question BI. Use the scalar product to find the angle between P and N. Formula is given in the data booklet, and it says that a scalar or a dot product of two vectors is x component by x component plus y by y plus z by z, so it's 0 times 0 plus 0 plus 0, so it's 0. And it's not necessary to write that it is equal to the magnitude of P times the magnitude of N times cosine of the angle between them, so that cosine of the angle between them is 0, hence these two vectors are perpendicular and the angle is 90 degrees. We can conclude directly from this that two vectors are perpendicular, hence the angle is 90 degrees. And it's clear without the scalar product when one point is on the y-axis and another on the z-axis. Clear that this angle is 90 degrees because the axes are perpendicular. The next shows that the distance between P and N along the arc from P to N is this value. so it looks like this. It's a radius, so it's 6. This is also a radius, so it's also 6. This angle is 90 degrees, and the length of this arc is required. And it's clear that it's a quarter of circumference, or you may use the formula that it's 2 pi r times theta over 360, where theta is in degrees, so 90 degrees over 360, or just 1 over 4 times 2 pi r. And to get directly in kilometers, so times radius, and it's the required value. The next point A, which is also on the equator, has position vector A with component 6, 0, 0, as shown in the following diagram. P, N, and A and the arcs connecting them form a spherical triangle. The angle at vertex A is defined as the angle between the vectors, between two vectors, this vector, and each vector is a cross product of two vectors. So the first vector is this cross product, the second vector is this cross product, and then it will be for the next. The angle between these two vectors, it's by definition the angle at vertex A for a spherical triangle. And question CI: find the vector which is equal to the vector or cross product of two vectors A and P. You may use the formula which is given in the data booklet. I use another formula that the required cross product is determinant of the next 3x3 matrix I, J, K, A with component 6, 0, 0, and P with component 0, 0, 6, and it is equal to plus I, and determinant of this 2 by 2 matrix, which is this product minus this product, and this 0 minus 0 is 0, minus J, and determinant of this 2 by 2 matrix, this product minus this product, so it's 36 minus 0, it's 36, plus K, and determinant of this 2 by 2 matrix, it's 6 times 0 minus 0 is 0. So it's a vector negative 36J or 0, negative 36, 0. Then shows that the angle at vertex A in the spherical triangle is 90 degrees. So we need this cross product for n, it's 0, 6, 0, and it is equal to plus I, 0 minus 0, minus J, it's 6 times 0 minus 0 is 0, plus K, and it's 36 minus 0, so 36. Or 0, 0, 36, and the required angle, it's just the angle between these two vectors, this and this. And it is given that it's 90, it means what dot product is 0, and we need just show it. So we consider the first vector dot product or scalar product, this vector I rewrite, but it's not necessary to be more clear that it's a dot product of these two vectors, and it's what, x by x plus y by y plus z by z, and it's clear that it's 0. And when a dot product of two vectors is 0, it means that these two vectors are perpendicular, hence angle is 90 degrees. The next, Moscow M has position vector OM as shown in the following diagram. The shortest distance between 2 points on the sphere lies along an arc of a circle on the sphere with center O. In this model, the shortest distance from Moscow to Nairobi is 6,000 kilometers. Question D shows that theta is 57.3 degrees, correct to three significant figures. So it looks like this. OM, it's a radius, so it's 6,000 kilometers. ON, it's also a radius, it's also 6,000. This angle theta is required, and the length of this arc is also 6,000 kilometers. So, using a formula for the length of arc, so this length of arc 6 is equal to the circumference 2 pi r in 1000, and our angle in degrees divided by 360. 6 cancels, and theta is 360 over 2 pi to be in degrees, and it's 57.2957 and so on degrees. Which is 57.3 degrees to three significant figures. The next, Bogota P is west of Nairobi and has position vector OB, this. Question E, find the shortest distance from Bogota to Moscow on the sphere. So this situation looks like this. Again, OM, it's a radius, it's 6. Then OB is also, the length is also a radius, so it's also 6. And we need the length of this arc. And to find the length of this arc, we need this angle. And this angle can be found as angle between two vectors, applying again what dot product. OM dot product OB is equal to the magnitude of OM times the magnitude of OB times cosine of the angle between them, BOM angle. You may write directly that cosine is equal to, but I want to find magnitudes firstly. OB magnitude, it's a square root of, where is it? It's the sum of squares of components, so it's 6 times sine squared plus 6 times cosine and squared and plus 0, and we can factor out 6 squared. It becomes multiplied by sine squared plus cosine squared of the same angle, and it's the main trigonometric identity, it's 1, so it becomes the square root of 36, and it's just 6. And OM magnitude is square root of And theta is this 57 point something, but it's not necessary to substitute because it becomes 0 plus 6 cosine of theta squared plus 6 times sine squared, and again 6 squared times cosine squared plus sine squared, which is 1, so it's root of 36. It's again it's also 6. And dot product OB OM is x by x plus y by y plus z by z, and it becomes OM OB. You can see 0 for x and 0 for z, and it becomes 6 times cosine of theta. It is acceptable to use 3 significant value, but it would be better to use the exact 57.2957 degrees and so on, and multiplied by 6 times cosine of 120 degrees, and it is equal to, it's not necessary to calculate separately, you may calculate directly cosine. It's negative 9.7254 and so on. And finally BOM angle is inverse cosine of this and divided by 6 times 6, and using a calculator it's 105, 673 and so on. It's not the final, it's not the final answer, so we keep the exact. Why? Because we need the length of this arc, and it's what, 2 pi r times our angle in degrees and divided by 360. And it's 3 significant figures. The next, the bearing from B to M is defined as an angle at vertex B in the spherical triangle containing B, M, and P. It is given that B cross product P is equal to this. Question F, using the method from part C, find the bearing from Bogota to Moscow. So the required angle is the angle at vertex B in for the spherical triangle and for the spherical triangle. You can see that at vertex A it's what, A cross product P, A cross product N, and then the angle between these two vectors. And absolutely similarly, it's triangle B, P, M. So we need the angle between OB cross product OP and OB cross product OM. And this is already given, so we need just cross product of OB and OM, and then the same formula with dot product to find the angle, and it will be the required bearing. So I rewrite that OM is this. It's 0. 6 times cosine 3 significant is acceptable, but the exact would be better. It's 57.29 and so on degrees. And 6 sine of 57.29 and so on. And OB is 6 sine of 120, 6 cosine of 120, and 0 is this. And then you may use the formula given in the data booklet that, and notice that we need not OM cross product, but OB cross product OM. There is a difference. You can see AA. So it's IJ K OB 6 sine 6 cosine 0 0 6 cosine 57 6 sine 57, and it is equal to I and this product, so minus this product, a determinant of this 2 by 2 matrix, and actually we can use the calculator and write the answer directly from the calculator. So it becomes I and 6 times cosine of 120 times 6 times sine of 57 point something, and it's negative 15.146 and so on. Then minus J and this determinant of 2 by 2 matrix, so it's this product minus this product, so it's 6 sine of 120 times 6 times sine of 57. It's minus J, so it becomes negative 26 point something, and plus K, and this product minus this product. And it's 16 point something. So it becomes negative 15.1464 and so on, negative 26.2344 and so on, and 16.8449 and so on. You may use the formula which is given in the data booklet and substitute directly to get this. And finally, the required bearing is the angle between two vectors. One vector is this and another vector is this. And let's write directly that the bearing is arc cos of dot product, and dot product is x by x plus y plus times y plus z by z, so it's negative 15.1464 so on times 36 times cosine of 120 plus y by y, so and minus minus, so it's plus, so it's plus 26.2344 and so on times 36 times sine of 120 and plus 0 divided by magnitude times magnitude, so magnitude of this absolutely similarly it's 36, and magnitude of this can be found as square root of the sum of squares. And it's 34 point something and then the inverse cosine gives us 29.123 significant figures. So since it's the bearing angle, so it's 0 to 9.1 degrees, or just 0 to 9 degrees, or as usual to 3 significant also is acceptable. And that's all for this question.